Learn. So you see the word calcite underneath there. And the orientation of the mineral will also contribute. You see how it changes? But that double appearance, that's what we call as double refraction. Does that make sense? So yeah, I thought that was pretty interesting. So zircon has a double refraction such that you can tell apart from diamond if you're getting turked into buying it. So don't get turked. Don't get turked. You guys ready to go over some zoisite? So first of all, actually, I'm going to pull up the Mndot page so we at least have some nice images to look at of this mineral because I don't have any samples except some heat-treated Tanzanite. Now, zoisite is actually in the Mndot group. So it's a dimorph of clinozoisite, which I don't really have very many notes on, but we're going to look at it nonetheless because it's pretty cool looking. This is what zoisite looks like in, well, the most beautiful samples of zoisite look more like this. I don't have any that look like this. Mine are not even a little bit translucent. They're so cloudy. That being said, they do have a transparent, translucent diaphaneity, so light can penetrate this. If you were to get this on the atomic level, you absolutely would be able to penetrate light through it, unlike a metallic. So I'm going to go over zoisite first. Again, this is it's an orthorhombic mineral. It is in the Mndot group, and it's also a dimorph of clinozoisite. It's in the silicates, which is the biggest group of minerals on the Earth's surface, but there's a ton of them. There are a ton of different silicates. I don't know how many off the top of my head. This is the variety of zoisite that's called Tanzanite. This is actually called, the pink variety has another name. I don't remember what it is. Thulite. Thulite is the other name. I don't know if anything will be on Mndot about it, or if it's an outdated term. Oh, no. It is a variety of zoisite, as is Tanzanite and clinozoisite. Let's look at those. So thulite is the pink variety. Named after Thule, the ancient name of Scandinavia. Really? This is named after the ancient name of Scandinavia? Usually the names are like directly applicable because of some way the mineral looks. So that is so strange. It has aluminium. It has a lot of stuff. Thule is North Wasteland in Latin? Really? Okay, so the original minerals. Zoisite is the group of minerals we're talking about right now. Tanzanite is a variety. So is Thule. And clinozoisite is a dimorph. So it's structurally different, but chemically the same. So we got zoisite. It's calcium, aluminum, silica, and oxygen. More silica and oxygen. Oh, what do you know? It's a silicate. Yay! It's got the SiO4 tetrahedra in there. That's what you need. So again, the mineral's orthorhombic. It's got a hardness of 6 to 7. I'm going to go up to the images. The specific gravity is actually a little bit higher. Not crazy, but it's a 3.15 to 3.37. This is one of the interesting things about it. Hardness of 6 to 7 mean. So hardness is actually the ease to which the minerals are scratched. So it has nothing to do with its tenacity. Now, I've had other people come in here and be like, hey, but that's toughness. No. Toughness is actually different in material sciences. In geology, the hardness is to the ease to which a mineral is scratched. And in this case, it's actually on the scale of 1 to 10, 1 being the softest, 10 being the hardest. 10 is diamond, 1 is talc. It's not a linear scale, but it is, there are more quantifiable ways to measure hardness, but this is simple, and this is very, very widely used and accepted. So 6 to 7 is, moderate. It's a bit higher in terms of hardness, but it's of course nowhere near diamond. So that is what hardness is. Now, you must be asking yourself, well, what about if it breaks? How does it break? What is that called? That's called tenacity. That literally has to do with, well, are we putting stress on this mineral, and when and how will it break? How will this thing deform? Will it deform brittly? Will it deform elastically or plastically? There are a lot of different ways. Yes, talc is 1 to diamond being 10. That's correct, Vicky. And yeah, but only 9 and 8. The others are almost linear albal. It's so weird. 7. No. Topaz is harder than quartz. 10 is diamond. I get topaz and corundum confused all the time, and I don't know why. One of them is 9 and one of them is 8. And then quartz is 7. I think, what do they use for 6? Maybe a feldspar? 4 is fluorite, usually. I don't remember what 5 is. Probably apatite. 2 is gypsum, I think. 1 is talc. 3 is, I don't know, calcite. I think. Those are just minerals with those hardnesses that they've picked to represent those things. It's the shape, Vicky, and I'm not going to be able to go much into the crystal classes with you guys right now, but it basically just has to do with, there's 6 different crystal classes here. So it's the shape that it produces. There's many in those 6 as well that can be produced. Usually you can click it. But crystallography isn't something I know a lot on right now. I'm gonna have to go back. But yeah, orthorhombic. Let's go with the Mndot Crystallography. No. It literally just has to do with the shape of the crystal. There's 6 different groups. This one being monoclinic. So earlier I said clinozoisite is a dimorph. Polymorphs, dimorphs, that just means that they have the same chemical composition, but their structure is going to be different. So in this case, this one's monoclinic, and this one is orthorhombic. And they have to do with the A, B, and C axes having different angles between them. And then they group them by that, in that way. And it's very, very, kind of dry, in my opinion. I wouldn't mind going back over it. It'll just be a minute. Cubic is, I think, isometric. I thought. No, it's not. I need to know now. No, there's not 7. There's not 7. Isometric, hexagonal, tetragonal, orthorhombic, monoclinic, and triclinic. Which one did we not have? Monoclinic, triclinic, orthorhombic, tetragonal, hexagonal. I think it's isometric, dude. Because orthorhombic is separate from isometric, man. That's dude, electron, that's my problem, is that I learned them a long time ago, probably a good decade ago. So we are going to go back over, again, this is over zoisite. Oh, there's actually no more than 10% of this mineral can be replaced by iron. Otherwise, the iron actually won't fit. So you can have up to 10% of some replacement in iron, but over that, it just won't fit. Thulite is pink because of the presence of no more than 2% manganese, Mn, which I thought was pretty neat. And thulite is this variety here, the one that somebody said looked like a Turkish delight. Kind of looks like raw steak. This one does. Looks like raw steak to me. But this is again just a variety of zoisite that is pink because of the presence of manganese. Anhedral grains are really common. This mineral only has one cleavage plane, so that one face is great. And then I think it does. It fractures conchoidally and uneven. So I've got a lot of samples that are kind of just really, really, well, they're shapeless, truly. They're just kind of shapeless. They're also very cloudy. They're not translucent like these other samples are. But one of the cool things about this mineral, there's one plane that gets really well striated, And you could see that there. And if you can, I'll show you in the microscope camera. But this plane here has really, really nice striations. So they look like little lines that are all parallel to one another. So in zoisite, twins aren't actually that common. Twins are where you would see multiple different grains, or I'm sorry, multiple different crystals growing out of one, I guess, central area. So, for example, little augite. There's a little piece of augite here that has a nice little twin on it. It's another little crystal right here growing off the main, just growing out the side of it. I love it. I think it's so cute. It's a little cute twin. Oh, this tourmaline though. Do you see all those different crystals protruding? This is black tourmaline. It's a variety called Schorl, Schorl. So zoisite typically doesn't develop very many twins. Oriented growths with epidote are possible, but this is epidote. I really, really like it. The samples that I have are pretty neat too. We've looked at some under the microscope camera since as well, and I really, really enjoy them. It's a very dark olive green. I love it. I think it's really pretty. It's a silicate. And zoisite actually is in the epidote group, so it would make sense. Makes sense. Zoisite, again, quickly, it's orthorhombic, hardness 6 to 7, specific gravities around 3.3. It can have up to 10% iron in the crystal lattice replacing in the octahedral sites. Thulite is the pink variety because of replacement of manganese in the crystal lattice, and hedral grains are pretty common. There's no real twinning happening. Oriented growths with epidote are possible. There's a perfect cleavage and an imperfect cleavage plane. And that's so far what we've gone over. You guys ready to continue? The tenacity of this mineral is brittle, so it's going to break in little pieces, but it does fracture conchoidally and unevenly. So there's only one cleavage plane that's really good. So that's why it's anhedral so often. The luster is vitreous. That's how shiny it is. So it's not adamantine like a diamond, and it's not metallic like, well, gold, but it is actually pretty shiny, because you can have minerals that are earthy and resinous and dull and pearly, all sorts of different terms to describe a mineral's luster. And it's the way that light is either reflected, absorbed, or transmitted through the mineral. The streak of zoisite is white. So going back to the topic at hand, I do want to try to get through this, all right? The streak, again, is just, you would take the mineral and literally drag it across a streak plate. And I've got two, and we did this last night. I've got a black one and a white one. They're kind of like little pieces of chalkboards. And if you have a white streak, then, or if you don't see it on a white one, let's see, I'm going to take one of my pieces of heat-treated Tanzanite. I'm going to try to scrape it and make a line here, right? Let's see if it's white. Oh, holy balls. It's white. That's the streak. I just streaked my minerals on stream. Oh, holy hell. So I think that's cool. Obviously, if you did it on the white plate, you wouldn't be able to see it. Streak it up. The colors of the mineral can be white, gray, greenish brown, greenish gray, and pink. Pink, again, is the variety that has manganese in it. The blue purples are typically heat treated. I don't know that those commonly exist. I think that they can exist in nature with the presence of vanadium in its crystal lattice, but I still don't think it's common. Even in the areas that they were probably found, they might even be mined out. Most of them are brown. Most of those samples from Tanzania are brown. And they are, again, heat treated. The mineral, okay, so Tanzanite does exhibit pleochroism. So what that means is, as you rotate the mineral, it actually can be different hues. So this actually does change from various shades of blue to purples. I don't see that in my samples because they're not great, but I would like to obtain something very obviously pleochroic so I could show you on stream someday. The best thing I think I have is a really weird variety of spodumene called hiddenite from the hiddenite mine, but it's so damn tiny you can't really see it. I can see it with here, but it's a tiny. The C-axis is the part that's a darker green. Oh, this mineral isn't actually commonly altered. It's common in medium grade metamorphic rocks specifically. It can be found elsewhere, but medium grade metamorphics are the most common place to find zoisite. Of course, the most valuable form of zoisite is Tanzanite, the pretty blue one that is usually heat treated, of course. Oh, and it's characteristic of regional metamorphism, which is really cool. So, like our other index metamorphic minerals, you could potentially find this and know that, oh, this is a specific type of metamorphism, because there are multiple types. Oh, you can get this mineral from hydrothermal alteration from igneous rocks as well. This is technically a sorosilicate, which is one specific type of silicate. There are many. Their refractive index is 1.69 to 1.7, and it's transparent to translucent. It comes from the various countries, at least in general. Some of the best areas are Spain, Germany, Scotland, Japan. Thulite, the pink variety, can be found in Norway, Italy, and in the U.S. Of course, Tanzanite, the variety of Tanzanite does, again, that one has vanadium in the crystal lattice, can come from Tanzania and Pakistan. I did not know that Tanzanite was mined in Pakistan, but it can be. I thought it was solely mined in Tanzania. So this is, again, zoisite. You've got clinozoisite, which is a dimorph. Tanzanite is one of the, oh my gosh. These are so pretty. Thulite is the pink variety, which is somewhat cloudy relative to the others. Let's see here. Originally named, salpite for the locality, Salp in Carinthia, Austria, where it occurs in eclogites. It was offered the name zoisite was introduced by A.G. Werner in 1805 to honor Sigmund Zois, Baron von Eldenstein. 1747-1819. Austrian scholar who financed mineral collecting expedition. Whoa, dude, that's cool. It was named after a guy who financed mineral collecting expeditions. What a good guy. What a great guy. That's a great guy. Don't you think that's a great guy? Oh, he funded expeditions for minerals, Mike. He funded, mineral collecting expeditions. I mean, I'm good with it. It probably helps science. What a great guy.